Good morning, students. So in last class we discussed that activating groups and deactivating groups. Activating groups like alkyl, amine, amino derivatives, all they are activating groups. OH group is also activating groups, and they can direct the ortho and para at the second substitution. Whereas in the deactivating groups like NH3 plus, COCH3, and cyanide NO2 plus, like these are the deactivating groups, they can direct the meta position. So why they are directing ortho and para means activating groups. In the activating groups like OH, NH2 are there. When electrophilic substitution takes place on the benzene ring, that positive charge of rhenium ion comes on the carbon which is attached to the activating group. So that activating group like methyl group, they directly gives electrons to the that carbon that rhenium ion by the inductive effect, whereas in the NH2 and OH which are having lone pair of electrons, they can donate electrons to the positive rhenium ion by the resonance effect. And there is more number of hybridized stable structures are formed in the ortho and para attack, whereas in the meta attack, that more stable structure not formation takes place, only three structures are possible. And so that's why ortho and para attack takes place when the activating groups are present on the benzene ring. Coming to deactivating groups like NH3 plus and COCH3 groups, cyanide groups, what happened? Already they are the electron withdrawing property, already deactivating the benzene ring. During electrophilic substitution, that positive charge of rhenium ion comes on the carbon which is attached directly to this deactivating group. What happened? More destabilization takes place. So more destabilized structures are formed in the ortho and para attack. Whereas in the meta attack, that positive charge is not coming onto the carbon directly which is attached to the deactivating group. That means that positive charge is missing from that deactivating carbon. So that's why somewhat stable structures are formed in the deactivating groups when the deactivating groups containing benzene ring on the meta attack. So that's why in the meta attack somewhat stabilized compounds formation takes place, stabilized rhenium ion formation takes place compared to ortho and para attack. So that's why they can direct the meta position. The two are okay, activating ortho para compounds, deactivating meta. But coming to here, why the halogens deactivate the deactivating groups? Okay, they are deactivating groups, but directs the ortho and para position. Why they are directing the ortho and para positions? The influence of halogens was analogous for the long time because chlorine, bromine, iodine being electron withdrawing and deactivating the nucleus when attached to the ring and leads to predominantly ortho-para substitution. So generally deactivating should direct meta, but here is they are directing for the ortho and para. Why means fluorine is least deactivating and fluorobenzene shows reactivity comparable to benzene itself. Same like it can be benzene. Ortho-para form 4 hybrid structures, whereas meta form 3 hybrid structures. In the same logic like activating groups, number of hybrid structures or stable hybrid structures are formed in the ortho-para attack is 4. Even though deactivating group like chlorine, bromine, fluorine is there, they can form 4 hybrid structures. Whereas in the meta attack, only 3 hybrid structures formation takes place. That's why these chloro, bromo, fluoro halogens, they can direct the ortho-para substitution. See, this is a chlorine is very deactivating group. It can take electrons, so the direction is this side. But and the positive charge also comes on this carbon which is having very deactivating group. But this can be taken. This positive charge can be taken by the chlorine by the resonance effect, the double bond formation. Chlorine itself, it is taking the positive charge from the benzene ring, and this is the stable structure formation takes place, and 4 hybrid structures are formed at the para attack. In the same manner, ortho attack, same. This positive charge comes onto this benzene ring, rhenium ion delocalization, and it can take this positive charge. Chlorine gets positive charge by the resonance effect, by the donating of electrons to the carbon, and itself it is getting the positive charge. 4 compounds are formed. So, whereas in the meta attack, what happened? Only 3 structures are formed. That positive charge not comes onto the this carbon, and the chlorine cannot give electrons to the this carbon, and it doesn't itself bear the positive charge. This can be not formed by the meta attack. Only 3 hybrid structures are formed, whereas in the ortho and para attack 4 hybrid structures are formed, and chlorine is itself taking the positive charge and giving the stable structure like this. This resonance structure formation takes place. During halogens, even though they are deactivating groups, itself they are bearing the positive charge and they are getting the these hybrid structures. So that's why ortho and para attack is preferable in the halogens present on the benzene ring, even though they are deactivating groups. This is the actual answer. Therefore, in halobenzene, the inductive and mesomeric effect are opposite to each other, but the inductive effect being stronger due to taking of electrons from the withdrawing of electrons from the benzene ring. Inductive effect means taking by a single bond and taking electron from the benzene ring, and itself it is bearing positive charge. Hence, deactivation takes place. The halobenzene also giving substitution reaction, but the rate is slower of the various forms of the ortho and para. 1C, 3B are most unstable. 1D and 3D are more stable. So this is about the why, even though chlorine, bromine, iodine, they are the deactivating groups, but they are directing the ortho and para position. Means the chlorine itself, it is taking electron from the benzene ring itself bearing positive charge, and more stable structure formation takes place in the ortho and para attack, whereas in the meta attack only 3 structures, resonance structures take place. So that's why ortho and para direction takes place in the halogens. That is the answer. So this is the about the effect of activating groups and deactivating groups. So that overall thing is here, what is benzene structure, how we can prove the benzene structure. Benzene is proved by the Kekulé. Kekulé given 2 resonance structures for the benzene, and at the end it is given the stabilized resonance structure. Benzene is stabilized by the 36 kilocalories. Why? Because benzene itself, it is not having only simple 3 double bonds and 3 single bonds. It is having 1.5 bond. That's why 1.39 angstroms is the bond length. Resonance stabilization takes place. Delocalization of the pi electrons takes place. That's why benzene is having all the hydrogens are same, all the bond lengths are same. So that's why it is undergoing mono substitution. Only it can produce only one substitution. Whereas in the disubstitution, it is giving the only 3 structures, not the 4 structures. Why? Because delocalization of the pi electrons are same. Always the double bonds are delocalized. That's why, as per Ladenburg question, they shown that only 3 structures are possible because delocalization of the pi electrons, and it can be all the another 4 structures are rejected, and only the first structure is preferred, and it is in the form of the Kekulé resonance structures. They are the interconvertible forms, and it is the benzene ring containing the resonance stabilized structure, and it is stabilized by 36 kilocalories. Why? Because means 36 means it should be 85. Actually, as per that, if it is containing 3 double bonds, it shows 85 kilocalories of energy. But it is showing only 45 kilocalories. That is, it can decreasing in the 36 kilocalories less than the actual energy. That means because of the delocalization of electrons, it is more stabilized and it is resonance stabilized structure. That's why it is 36 kilocalories stabilized resonance structure. Okay, so benzene, it is undergoing only electrophilic substitution reactions. Why electrophilic substitution reaction means benzene itself, it is having rich of pi electrons. That lone pair of electrons are present on the pi electrons are present on the each carbon containing p orbital. Each carbon is in the form of sp2 hybridized form, and another p orbital is having only one single electron. All each carbons of single p orbital containing one electron is undergoing delocalization and forming the delocalized pi electron ring. So that's why benzene structure is a planar in nature, and it is the pi cloud is present on the above and below the plane of the benzene ring. That is, a more stabilized benzene structure is formation takes place. Okay, so that is about the benzene ring, and it undergo electrophilic substitution means rich of electrons, so that's why it can readily accept the electrophile which is deficient of electrons, and it always undergoing substitution, not addition. Why? Because if the addition takes place, bond breakage takes place, it can be destabilized. So whether the substitution takes place, the bond break cannot be takes place. There's more stable benzene structures similarly present in the form of delocalized pi electrons. So that's why it undergo electrophilic aromatic substitution reactions. So electrophilic substitutions is nitration, sulfonation, halogenation, Friedel-Crafts alkylation, and Friedel-Crafts acylation takes place. In that mechanism is, first one is the formation of the electrophile, second one is the formation of the rhenium ion, and after that removal of the proton by giving electrons to the benzene ring. This is the 3 steps. And next, this is the mechanism of the electrophilic aromatic substitution, that is mono substitution. If we are going for the di substitution, the already presented compounds act as a activating groups or the deactivating groups. If the electron donating property is there, we can say electron activating groups. If the electron withdrawing property is there, they can say deactivating groups. So how they can activate means by the two effects, that is the inductive effect or the resonance effect. They can donate electrons to the single bond, we can say electron inductive effect. They can donate electrons to the double bond by the overlapping of pi electrons, that is called resonance effect. So simply CH3 alkyl groups, it can donate electron by the inductive effect, whereas the NH2 group, OH group, which are having the lone pair of electrons, they can give electrons to the benzene ring by the resonance effect, by the double bond formation. So by this they can activate or deactivate. Deactivating groups are NH3 plus and COCH type of compounds. So they can deactivate the ring by resonance effect, and they can deactivate the ring by the inductive effect also. So like this takes place, and mainly activating groups, they can direct the ortho para position. Why? Because at the ortho and para position, more stable structures and more hybrid structures or formation takes place compared to meta attack. So that's why activating groups always directs the ortho and para attack, whereas the deactivating groups, they can direct the meta position. Why? Because compared to ortho and para structures, here somewhat stable 3 structures only formation takes place, but only the less destabilized structure formation takes place in the meta attack when the deactivating groups are present. So that's why always deactivating groups always directs the meta position. But only the halogens, why they are directing the ortho and para attack means, these halogens, even though they are deactivating groups, they are taking the electrons from the benzene ring by the inductive effect, and they are itself bearing the positive charge and giving more stable hybridized structures. 4 hybrid structures or formation takes place in the ortho and para attack, but only 3 hybrid structures or formation takes place in the meta attack. So that's why these halogens are having the ortho para directing property. This is about the total benzene class.